So let's get started. This webinar aims to enable you to engage your nonprofit organization in its first machine learning project by providing you with a basic background on data concepts, machine learning categories, and machine learning for production. Um, I should add that there's no need to have coding background or math background to understand the concepts of this webinar. It's pretty beginner friendly. There will be Q&A at the end, hopefully, and there are polls throughout the webinar, so please keep a mouse handy to participate in polls. So let's get started by understanding how machine learning connects to this big buzzword nowadays, which is artificial intelligence. Machine learning is one of the most recent paradigms under the large umbrella of AI compared to older paradigms like rule-based systems, although there are still handy and there can be overlap between different paradigms. But machine learning systems, they derive patterns from data, and they are used when rules are unknown or impractical to define. They are adaptable and improve over time as they see more data, but they demand a lot of data, compute power, they are complex, and they are harder to maintain. So that gives you a background about the qualities of machine learning systems. It is important that we understand machine learning as only one of the tools in our toolbox when we are making informed decisions in our organizations. So here I'm going to walk you through a few example tools, and I'm going to put it in the context of an organization that is receiving calls, external calls, in order to see how this is going to work out. For example, in terms of quality control, we can ask ourselves if we are controlling satisfaction of the callers, and if we have tools in place for that. Descriptive analytics, which sometimes we refer to it as exploratory data analysis, can visualize and show us any trends in peak call times or any frequency in call reasons or call durations. Statistical inference can tell us if callers to a specific department are significantly happier or less satisfied than other departments. Machine learning, however, can, for example, automate these calls, and we're going to discuss that more in the following slides. And mathematical optimization, for example, can be used to schedule staff shifts so that at the time of high call volume, we don't run out of resources. So the takeaway from this slide, which is very important, is that machine learning is not a silver bullet. It's not the answer to all of our prayers, and it's only helpful sometimes. It can inform us, it can help us, but at other times we have to resort to other tools. Now, if that's the case, let's see when machine learning can be most useful for us. So here I have made this diagram for you. And finally, clustering. So this is a little bit different. Suppose that we work for an organization involved in animal welfare and environmental preservation. And we have a large number of articles written about different animals. And we want to find a way to cluster them, to group them for ease of access and understanding and similarities. So how should we do that? We don't already have any classes to categorize them. Well, an algorithm may find different ways to do that for us. In this case, maybe algorithm decides, like this one, to categorize them into animals that lay eggs and animals that do not lay eggs, or maybe categorizes that into birds, fish, mammals, and reptiles. And so, as you can see, there are different ways to cluster the same data. It's just a matter of finding interesting patterns in there. So here is a summary of everything that we discussed. Regression, it can predict continuous outcomes for us. The example is predicting house prices based on features like size, location, number of rooms, so on and so forth, a combination of those. Classification is when we classify data into predefined classes. That's the key, to be predefined. And An example is identifying which department a caller must be connected to. In this case, each department is a class. And clustering, which groups data points into clusters based on similarity. For example, segmenting donors into groups based on donation behavior for targeted marketing. All right, let's put our understanding to test here. We have a poll related to human trafficking hotline. Since 2007, Polaris has operated the U.S. National Human Trafficking Hotline, connecting victims and survivors to support and services. To manage and prioritize the increasing influx of the calls, this nonprofit has implemented a voice bot capable of listening at scale and triaging the calls. As a result, more staff time is available to engage with calls from victims and survivors with urgent needs. Question: which option best describes the functionality of this machine learning system? Regression, classification, clustering. Let's give it 15 seconds. So we essentially looked at most of the parts of this proof of concept diagram. Before we move on to the second part of this webinar, I want to share an idea with you with regard to applications of machine learning. I already wrote and posted a blog post which contains a lot of different applications from the survey that we ran about this webinar beforehand. I know that a lot of you are looking for ideas for implementation of machine learning. I think this blog post really contains a lot of ideas and a lot of examples and links to useful resources. So I hope you take a minute to go through this at a later time, and hopefully this will help you discover more. All right. Now, moving on to the idea of production versus proof of concept. This diagram, as we mentioned a few times, is for proof of concept, experimenting, playing around with machine learning models and learning from them. However, in reality, a developed machine learning model, it takes a lot more to implement such a model in real life. And even though this diagram on the right side of the screen is still simplified, it shows you a few more steps involved, and we call this machine learning project lifecycle. So let's put this in the context of a case study. Again, our case study is interactive voice response system. Let's say this person has a question in mind. My nonprofit organization receives a lot of calls. How can we develop an IVR to route the calls? So to help this person, we're gonna walk them through different steps of this project lifecycle, machine learning project lifecycle. Let's start with problem definition. As a final summary, as we're coming to an end, I wanted to just review some basic things that we learned together. We started by learning about how machine learning is related to AI, and when machine learning is useful, it's only one of the tools in our toolbox. We discussed some basic concepts of data, like labeled versus unlabeled data. We learned structured versus unstructured data. We discussed structured data in depth. We reviewed some ideas of data wrangling and feature processing as well. In terms of machine learning, we discussed regression versus classification versus clustering, but we also discussed supervised versus unsupervised learning paradigms. And finally, we differentiated between proof of concept and machine learning for production. We understood that in real world, machine learning implementation is more complex, and we went through the life cycle of machine learning projects. I would like to leave you with some additional resources.